Okay, now we want to look at reflection through the x-axis, which is defined in a way very similar to the reflection through the y-axis. Matter of fact, we just take this set of instructions here and replace y with x. So that, for example, if we wanted to reflect this point, we would move in the y direction. I guess we also have to replace the word horizontally with vertically. Okay, so let's do that. Vertically, and I'm going to change y a bit clumsily to x. And then down here, my statement about right, left, mirror image is now up, down. Okay, so this point is going to be the reflection of this point. And similarly, this point will reflect down here, but it's down in my writing, so I'm not going to do it. If it was this graph, this point would reflect down here, etc. It should be very clear, if you know how to construct a y reflection, that you can construct an x reflection. And then if the original function is f of x, what's the expression for its x-axis reflection? What about an exponential function through an x-axis reflection? You can ask all the same questions. Now, the main question I want to ask right now is, do we really need reflection through the x-axis? And we actually don't, if the answer to this question is yes. The question is, does a vertical stretch by factor, and I guess I should have the word by in there, vertical stretch by factor -1 constitute a reflection through the x-axis? Now remember, a vertical stretch is generally defined, when I defined it, as what happens if you multiply the y-coordinate of every point by some constant factor. Okay, so you have a constant constant factor by which all your y-coordinates are multiplied. So if I multiply a y-coordinate by -1, what does that do to my y-coordinate? What will be my new y-coordinate, and does that relate to the idea of reflection through the x-axis?